conduct our discussions today about soil. Remember, we have been covering soil experiments, and we have been giving you some assignments to go and research. Did you do the research?
Yes.
Where are the members of Group 1? Group 1 is here. What are you researching about?
Soil pH.
The soil pH, right?
Yes.
Are you ready with the experiments?
Yes.
Then Group 2?
Living organisms.
The living organisms, soil organisms, right?
Yes.
So we shall be interested in those experiments. And then Group 3, what are we presenting? Water drainage and retention. So without wasting time, if the groups are ready, are we ready?
Yes.
Let's join hands and welcome Group 1.
My name is Senor Roderick, alongside Chikarika. We are from Group Newton. We are going to talk about the pH of soil. We discussed in our groups that the pH refers to the acidity or alkalinity of a substance. But for this time so long about soil, we are going to determine the acidity or alkalinity of the different soil samples. We came up with the different soil samples. We have here the loam soil, which is X, the sample X. We have here the sand soil, which is sample Y. Then we have here the clay soil, which is sample Z. For all these soil samples, we carried out different experiments, the same experiment, but they carried out the same procedures. And we came up with the results here. But before continuing, let's first talk about what pH is and what we mean when you talk about the pH of the soil. First of all, when we are determining the pH of soil, we mainly use the pH scale, which is here in the chart. The pH scale, ranging from 0 to 14. From 0 to 7, all these values within this range. If we test the soil sample and we confirm that we have a certain value within this range of 0 to 7, that sample is acidic. Which means our soil sample, we can tell that we have an acidic what? An acidic soil. Then we begin from, if we get values from 7 to 14, within this range, then we confirm that we have a soil sample which is alkaline. To mean acidic, acidic mainly hinges on the concentration of hydrogen ions. Yes? Which means acidity of the soil is determined by the concentration of hydrogen ions. The greater the concentration of hydrogen ions, yes, is the more acidic the substance becomes. Yes, I'm understanding. The greater the concentration of hydrogen ions, the more acidic the substance becomes. And if we have a low concentration, like a low concentration of hydrogen ions, also the solution is very like it is not very acidic. But if we come to the side of alkalinity, we mainly base on the presence of hydroxyl ions. Yes, hydroxyl ions. For example, we can talk about beginning from 7 to 14, these values within here. I think you are seeing on our pH scale. From 7 to 14 increase in alkalinity. And from 7 below, going towards 0, we have increasing acidity, which means also that the higher or the bigger the value, the higher the alkalinity. Yes, the bigger the value, the higher the alkalinity. For example, if you test your soil sample and you have a value of 12, 11, or 13, 14, which means it is highly alkaline, and if you have a value of 1, 2, 3, 4, all these values, they are low, which means it is highly acidic. Then this is what we carried out to confirm what the pH scale is showing us. We got the first soil sample, which was loam soil. We poured a small proportion in our beaker. Then we poured water, a small proportion of water. Then we shaked. Then we left it to settle for 10 minutes. Then afterwards, we filtered off this solution. Yes? After getting this solution, we poured it in this beaker here. Then after pouring it in this beaker, we got our universal indicator. We used the dropper, then we put here 5 drops of the universal indicator, and this was our result. Then if you get the color here, you come on your pH chart. You come on the pH chart. Then you look for the color range on the pH chart. For example, this one, it's around here, this color here, the value is 6. And on our pH chart, on our pH scale, if a solution presents a value of 6, which means that solution is acidic, because the values that range from 0 to 7, all these values, the solution is acidic, which means this is an acidic soil for the sample we used. Then we went to the second sample, we followed the same procedures, and these were the results. This was from soil. If you compare this solution with the pH chart, we get this one, this value here. Yes, this value here. This is the value we get, which is 8.5. Then if you come on your pH chart, 8.5, in which range does it fall in? In the range of 7 to 14, which means the soil is alkaline, which means it has an alkaline pH. Then we want the third sample, which was the sandy soil. We followed the same procedures and we got out this solution. We tested it with the universal indicator, and if you compare the color, we got this one, which is 7. Yes, we get 7 here. That's what we get. Which means, and remember here, if we are dealing with this value here, the soil is what? Neutral. For a substance to be neutral, the concentration of hydrogen ions is equivalent to the concentration of hydroxyl ions. That's which means in the sand soil we're having, the concentration of hydroxyl is equivalent to the concentration of hydrogen ions. Then, I think that's what we discussed. We are questioning the members. If you have any question for us, you can ask any question.
I want to grow onions, and I test the soil, and I find out that it's alkaline. What can I do to reduce the alkaline?
Great question. I looked about that onions grow best in acidic soils. What do I do to reduce the acidity? Yes, so that I can be able to grow the onions. Then this is what you do. There are different substances that you can add to the soil to reduce its alkalinity and increase its acidity to the value you want. For example, you can add, we have ammonium sulfate, we have diammonium phosphate, phosphate. Then also the traditional you can also use animal droppings.
Are there other ways of determining the soil pH without using a universal indicator?
Great. Yes.
We can use the litmus paper, and also we can use the pH meter.
Yes, you can use the pH meter. You have the litmus solution, but the most accurate one is the pH meter, and also the universal indicator. So those are the best ways. You can use the universal indicator or the pH meter. Thanks so much for your attention. That's what we discussed about soil pH. Thanks so much.